Hello students, in the previous lecture we have started the paper first of S.Y.B.Sc. In that the first chapter it is the phase equilibrium. So this phase equilibrium concept, it is very important in determination of the properties of the individual components or the properties of the system. The system we have already defined, it may be made up of different types of the states of the matter, liquid, gases or solid. It may be the mixture of the liquid, solid, gases or any variables. So this system is very important, which is isolated from the any other substances. Then second point important we have studied is the phase. So phase is the appearance of the corresponding chemical substance or states of the particular substance. So state is nothing but the phase, and this phase it may be formed by the combinations of the liquid-liquid, liquid-solid or solid-gaseous. So phase is the part of the system that can be the different according to the chemical constitution. And third is the component of the system. So component is the chemically distinct species that can be separated by mechanical treatment. So the component is the individual constituent of the system which is independent of the nature of the system or the properties of the system. So these 3 points are very important in studying the phase equilibria. The next point we are going to see the phase rule. So this phase rule that will describe the properties or that will give the condition or the how the system will varies with the temperature, pressure and the molar concentration, molar entropy and the composition. So all these are the intrinsic properties. So this phase rule it will give the concerned with the intrinsic properties of the system. So these intrinsic properties are again independent of the quantity of the substances and again the size of the substances. So when we consider any system, that is always made up of the different types of the components and it will form the different types of the phases. Now when we consider the examples, different examples of the intrinsic properties, for example pressure is there, temperature is there, concentration, density, molar entropy, these all are the intrinsic property of the system, and these properties, these may be get changed depending upon the pressure, depending upon these variables or at equilibrium we can study the intrinsic property. So at equilibrium the steady state is obtained from the system, and at that equilibrium we can define, we can give the degrees of the freedom for these individual components. So degrees of the freedom it is indicated as the corresponding properties of the system again. So from the degree of the freedom again it is related to the intrinsic property. So degree of the freedom is nothing but the some intrinsic property of the system are kept fixed in order to study the remaining or the other intrinsic property of the system. So what we are doing, we are keeping the fixed property, some property, for example pressure may be kept constant and we will change the temperature of the system, and accordingly we are getting the phase diagram and we will study the variation of the system with respect to the component. So that will give the degrees of the freedom. So these degrees of the freedom are important, that are related to the properties, variables and the intrinsic properties of the system. Now this system it is independent of this Intrinsic properties are independent of the quantity and size, and it will describe this system, any system completely. So complete knowledge or complete description of the system can be given by describing, by giving the values of this intrinsic property for the component of the system. So this is degree of the freedom. It is related with the phase rule. Now if there are 0 degrees of freedom may be possible for the component, maybe 1, 2, 3, and accordingly it is called as non-variant. If the 0 degrees of the freedom is possible for the system, or there is 0 degree of freedom, for example for the water molecules, when we consider the system as water is present in the liquid state, it is in equilibrium with the vapor state, and again it is equilibrium with the ice. So these 3 phases are present here, but the degree of the freedom, it is found to be 0. So if degree of freedom it is 0, it is called as the non-variant. If it is 1, it is called as monovariant. If it is 2, it is called as trivariant, tetravariant, pentavariant accordingly. So we can describe the system completely by using this type of intrinsic property, which may be changed, and this degree of the freedom will helps to define or describe the properties of the system. Now here the ideal gas equation, we are very well known about this. PV is equal to nRT. So in this equation, if we study this equation with respect to the particular system, then in that system if we change the pressure and temperature for the system, then we are getting the different values, and we can calculate the number of freedom, degrees of the freedom. So for this system, the degrees of the freedom, it is found to be 2. So this system, it is called as the bivariant system. It is called as bivariant. Now this equation is given, C equals to N minus E. So this equation, it will useful for determination of the components properties, or we can also determine the degrees of the freedom. Now here C is the number of the component present in the system, N is the number of the chemical species which is present in the system, E is the number of independent equations relating the concentration. So number of the equations may be given related to concentration of the species or the component. So if the concentration of the species is known, we can determine them by, we can put them by equation. So we are getting the corresponding value of the E. So number of the independent equation relating the concentration can be given for the system. So from this equation we can determine the degrees of the freedom for the any system. Now phase rule is always concerned with some intrinsic properties. So in this case P and T if we consider, so for system some intrinsic properties are kept constant, so that we can study the properties of the system, or we can study the other properties of the system. So in this example we can say the for example for the system it is given for the gas. So system containing gas molecules or any gas component, for that we can use this equation PV is equal to nRT. So in this case pressure and temperature is changed, we are changing the pressure and temperature, and we are studying the other properties. For example volume is there, so it is kept constant, the N number it is constant, N is constant, and R is the universal gas constant. So in this example what happens, if pressure and temperature it is changed, then we can determine the volume for the corresponding system. So especially when gaseous system is given, so we can apply this equation to that particular system, and we can determine the correct volume for the component of the system or the overall system. So number of the freedom is again important. So that will give the number of component here C. N will be the number of chemical species here. So we can determine the chemical species, we can determine the number of the components, and these are the number of independent equations that will related to the concentration of the different types of the species which are present in the medium. So this is about the degrees of the freedom. We have studied some examples. So in the next lecture we will see the different types of the system that can be changed with the different variables. Thank you.